In this problem, we have to solve for positive integers. The equation is given, that is 2 raised to the power x plus 2 raised to the power y is equals to 2176. So you have two unknowns, x and y are the unknowns, and one equation. How will you solve this problem? And one extra condition is given that x and y are positive integers. These kinds of problems are generally solved using factorization method. But before factorizing this equation, you can notice there is a cyclic symmetry in the equation. For example, in this case, if I replace x with y, so I will have 2 raised to the power y, and y with respect to x, so I change y with x, so this will be 2 raised to the power x, and we have 2176. That is the same equation, only thing is order has changed. X was earlier here, now x is in the second position, y was earlier here, now this is at the first position. So order has changed, otherwise the equation remains same. So there is a cyclic symmetry in this equation. So these kinds of problem you can do by sorting. So let us do some assumptions. So I am making an assumption, and we will relax this assumption towards the end of this problem. So let us say x is less than equal to y. So this is the assumption I am making. This means y is a bigger number. So y can be written as x plus something. So let us say I can write y is equals to x plus k. And you see x, y are positive integers. This means x and y belongs to natural numbers. This means k also belongs to natural number. So I can say x, y, z all belongs to natural number set. So this all belongs to natural number set. So let us plug the value of y in this equation. So you have 2 raised to the power x plus 2 raised to the power y is nothing but x plus k, and this is equals to 2176. Now you see, if you have, so there is a formula in the power, if you have a raised to the power m plus n, and this can be written as a raised to the power m times a raised to the power n. So I will use this formula. So if I use this formula, I can write this becomes 2 raised to the power x plus 2 raised to the power x times 2 raised to the power k is equals to 2176. Now I can take 2 raised to the power x common. You see, here you have 2 raised to the power x, here also you have the same thing. So I can take this term common. So I can write 2 raised to the power x, this becomes 1, and this is 1, this is 2 raised to the power k, and this is 2176. So now my equation becomes simpler. Now we have two factors. One factor is 2 raised to the power x, and another factor is 2 raised to the power k plus 1, and this is equals to 2176. Now I can factorize this number. So I have a number on the right hand side. So on the left hand side I have two factors, that is this factor multiplied by this factor. But on the right hand side we have only one factor. So why not we factorize this factor? So let us say 2176, and we can divide by different numbers. So let me put these places because we will require this. So let us say we start with 2. So if you divide this by 2, then you will have 1088. Further divide by 2, 544. Next 272. Next divided by 2, that is 136, 68, 234, and then divided by 2, that is 17. So how many 2 you have? 1, 2, 3, 4, 5, 6, 7. 7 2's. So this means now I can write this expression as 2 raised to the power x, 2 raised to the power k plus 1, is equals to 2 raised to the power 17, no, not 17, 7 multiplied by 17. Now you see the parity of this equation. Here you have one term 2 raised per x. Here also you have something 2 raised to the power. Another term you have, that is 2 raised to the power k plus 1, and here you have something like this 17. So k is also a natural number. This is not z, this is basically k. So k is also a natural number. Consider the two parts of k when k is equals to 0, and the second part is when k is equals to some positive number that is greater than 0. So we'll consider two cases. The first case when k is equals to 0. Now in this case what will happen? 2 raised power x times 2 raised power 0 plus 1. This is equals to 2 raised power 7 into 17. So you will have, this is 2. So 2 raised power x times 2 is equals to 2 raised power 7 times 17. So this will never be satisfied because we have even number this side and this side we have an odd number. So there is no solution for this case. K equals to 0, no solution. Now the second case we can have k can be any number but greater than 0. In that case what will happen? You can simply compare the parity. Then 2 to the power x is equals to, so let me write 2 to the power x into 2 to the power k plus 1. This is equals to 2176, which is equals to 2 to the power 7 into 17. This means now if I compare the parity, I can say x is equals to 7. And what will be the k? So 2 raised per k plus 1 will be 17. From here I can say 2 raised per k is equals to 16. So k is equals to 4 because this is 2 raised per 4. So k is equals to 4. So the y value will be, y is basically x plus k. So this is x is 7 plus 4, that is 11. So what is the solution? So my solution set for xy is, I will have x is equals to 7 and y is equals to 11. But now we have made an assumption, that is x is less than y. If I don't make this assumption or I make the reverse assumption, I will get the same set of solution. Only thing is I will have 11 and 7 as, if you solve this all, you will find 11 and 7 as solution. So for this problem you have two sets of solution or two pairs of solution. One is 7 and 11, another is 11 7. So I hope you enjoyed this video, and if you enjoy, please share with your friends, like this video, subscribe to my channel. Thanks for watching this video, and I will see you in the next video. Thank you.